In this lesson, we will discuss bond energies. You should not expect every atomic bond to be of the same strength, where some are stronger than others, and this strength is measured by bond energies. So the stronger a bond is, the higher the value of the bond energy. As we proceed, we will examine how we can use bond energies to have an idea of the energy changes that take place during reactions. The first point that we will discuss is making and breaking bonds. So imagine breaking the chemical bond between two atoms in a molecule. Well, what is a molecule? A molecule is a group of two or more atoms which are bonded together. Of course, you would need to provide energy to separate atoms, which is similar to separating, let's say, a pair of magnets attached through opposite poles. You'll have to put in energy to overcome the attractive forces between the atoms and break a bond. And since breaking bonds requires energy, it's thus an endothermic process, which is a process that absorbs energy. An endothermic process absorbs energy from its surrounding, causing a decrease in temperature. Check the example of the H2 molecule. This molecule is made up of two hydrogen atoms which are bonded together in a single covalent bond. Then let's check how we're going to break this bond between the two hydrogen atoms. When this bond is heated, where heat is a form of energy, this bond breaks down, so breaking bonds requires energy and thus is an endothermic process. So the bond will break when energy in the form of heat is applied to the bond. On the other hand, making a new bond releases energy, so this is an exothermic process. In this case, we have two hydrogen atoms and a new bond will form between these two hydrogen atoms. So energy is given out when the two atoms are bonded together. Where making new bonds gives out energy and thus is an exothermic process. Now let's recap while completing each sentence below. Bond breaking is it an endothermic or an exothermic process? Well, does it need energy to be added or will it release energy? Remember that to break a bond, energy should be added, therefore it's an endothermic process. On the other hand, bond making or building will release energy, thus it's an exothermic process as we've mentioned before. In general, we can think of any chemical reaction as a two-stage process. In the first stage, the bonds of the reactants are broken. Then new bonds are formed to make up the products in the second stage. Let's check now the energy level diagram for an exothermic process. So the left axis represents the level of energy in the system. Here's the level of energy of the reactants, and there is the level of energy of the products. Then starting from the left, in the first stage, the bonds in reactants are broken, so energy is needed to break down the bonds between the atoms of the reactants. Energy is needed, thus this is an endothermic process, and this process is represented by a blue arrow pointing upwards, so more energy is absorbed into the system, which raises the energy of the system upwards. The second stage of the chemical reaction will be the formation of new bonds, and thus obtaining the products, where this is an exothermic process, and we represent this stage with the red arrow pointing downwards, so energy is released from the system. The difference between the energy needed to break bonds and the energy produced when new bonds are made is delta H, or the enthalpy change of the reaction. The reaction being the process of going from reactants to products. In this case, it's negative, going from left to right. Since the products have less energy than the reactants, where energy is released, or as we can observe, more energy is released than absorbed while moving through stages 1, gaining energy, and then into 2, releasing energy. On the other hand, in an endothermic reaction, the products have higher energy than the reactants. Thus, the energy needed to break bonds is greater than the energy released when the new bonds are made up, meaning that more energy is absorbed into the system than released out of the system while moving through stages 1 and 2. Then delta H, the enthalpy change of such reactions, is positive. Thus, it is an endothermic reaction. So you shall keep in mind that in an exothermic reaction, products have lower energy than the reactants since energy is released in the reaction. Whereas in an endothermic reaction, products have higher energy than the reactants since energy is absorbed into the system during the reaction.